Hello, algebra students. This is Mrs. Carrivo. Today we are going to do a little review of some basic solving. So we're going to go through way back to the 1-step and 2-step and just those basic equations. Hopefully this whole thing will be review for you. It really should be, but we're just going to kind of bring it back up in our memories and make sure it's fresh. And we're also going to really practice ways to make sure that we're showing our thinking very clearly and very organized, because we are going to get into some much more complicated equations very soon here in 930. So this is just kind of our basic building block. So if you feel like you know these, that's great. Just focus on keeping organized, showing good work. At any point, if you want to, you can always pause the video, try to do the problem on your own, and then fast forward to see if you got it right and showed good work like I do in the video. So, but if you don't remember anything, that's what I'm here for. We're going to go through them together. So these top three, these would be our warm-ups, right? These are just our one-step equations. So if I'm looking over at number 1, it says x plus 8 equals 97. And remember, when I'm trying to solve, that means I need to get the variable by itself, right? So I'm trying to get this x by itself. Now, we might be able to do some mental math here, but we really want to make sure we're showing our thinking. So I say, okay, some number plus 8 equals 97, which means I need to get that 8 to be moved over to the other side of the equal sign. And remember that when we are solving, if we want to move something to the other side of the equal sign, we always think, what is the inverse operation? So what is the inverse or the opposite operation of adding 8? Well, the inverse would be subtracting 8. So we're going to make sure we show our thinking by showing that I'm subtracting 8 on that side, but also subtracting 8 on the other side. Now, I have a lot of students who really like to draw a line down through the equal sign just to keep track that they are doing the same thing on both sides of the equal sign and not doing two things on the same side. So here, if I'm subtracting 8 on the left, plus 8 and minus 8, the reason they're inverses is because they cancel each other out, and I won't have anything left, right? It'd be 0. X plus 0 is just x. On the other side, then, I have my 97 minus 8, which gives me 89. So that's how we would show good work, is that we would make sure that we're showing that inverse operation. All right, number 2, I have negative 5x equals 100. Now, hopefully you are remembering, but maybe it's something a little bit new. When in algebra, a lot of times I will have a number written right next to a variable like this. And when I have a number written just smashed right up next to a variable, that implies that we are talking about multiplication, right? So negative 5 times x. So if I need to do the inverse operation, what would be the inverse or the opposite of multiplying? So I'm going to divide, right? The opposite of multiplying is dividing. So when I have two numbers written, or a number and a variable, a constant, a coefficient, and a variable written right next to each other like that, it means multiplying. So the opposite would be to divide. So here I want to go, here's my equal sign, right? So to get rid of that negative 5, it's negative 5 times x, so I would like to divide by negative 5, and we can divide by negative numbers. That's okay. Now, just like we talked about earlier last week, we talked about how we try to want to stay away from using the x for times in algebra. We also want to try to get away from writing that old school division symbol. We're not going to do that much anymore. In algebra, we always write division with a fraction bar. So again, I know you won't remember every time, but let's do our very best to write division as a fraction bar. Right, division as a fraction. You'll kind of find out why soon, but it's just going to really help you keep more organized as you go along here. So we're dividing both sides by negative 5. Now again, we do the inverse because it really means that they are going to cancel out, right? Negative 5 divided by negative 5 is like multiplying by 1. 1 times x is just x, right? So we can just cancel those out. 100 divided by negative 5 would give me negative 20. So x equals negative 20. And again, that's how we're showing our good work and showing our thinking. All right, now number 3, and I have a fraction here. Now, we just talked about this, right? Well, what does the fraction bar mean? The fraction bar means division, right? So what is that? The inverse operation of division. So the opposite of dividing would be multiplying, right? So if I have x divided by 3 equals 17, then to show my thinking that I want to do the inverse operation of dividing by 3, I'm going to show that I'm going to multiply by 3. And remember, we're going to try our best to not use x for times anymore. Now remember, I draw that line down because I only want to multiply by 3 once on the left of the equal sign and once on the right of the equal sign. So over here on the left, I have a fraction, and sometimes students get goofed up and they want to multiply on the top and the bottom, but look how that wouldn't be even anymore. I'd be multiplying twice on the left and only once on the right. That's no good, right? So I don't want to multiply twice. I just want to multiply once on the left and once on the right. Now, again, here it says x divided by 3, and then times 3, because divided by 3 and times 3 are opposites. They're going to cancel out, right? It's like I multiplied by 3 on the top of the fraction, and I already have a 3 on the bottom of the fraction. 3 over 3 would become 1, so it would be x times 1 is just x. So again, remember, once on each side. 17 times 3 then would be 51. All right, so those were review. Those were our just one-steppers. Now I would think at this point you kind of have the idea of how we're going to show good work. If you want to try these problems, pause your video, see if you get them right. You totally can. Now, because I have more than one thing going on, I'm going to make sure that I draw this line down the equal sign, right? And make sure that I'm only doing one thing on each side. Number 1, I have negative 2x minus 1 equals 9. Now I have more than one thing going on over on the left. So the question is, which one do I get rid of first? Do I move the negative 2x first, or do I move the negative 1 first? Because I'm trying to get that x by itself. So remember, we know our order of operations, right? PEMDAS, parentheses, or GEMDAS, grouping symbols, right? Grouping symbols, exponents, multiply and divide, same level, add and subtract, same level. So when I'm solving, I want to do the opposite order of operations, right? Just like I'm doing my inverse operations. When I'm adding, or when I'm solving, I want to do the opposite of the order of operations. I want to get rid of the adding and subtracting first. Then I want to get rid of multiplying, dividing, get rid of exponents last, right? So, excuse me. That's kind of what we're thinking. So here I have negative 2x. Remember, this negative 2 written right next to the x really means that it's being multiplied by x. So that's not going to be the first thing that I do. This one just says minus 1, so I'm subtracting 1 from the x. So there's my adding and subtracting. So the negative 1 is the thing that I'm going to move first. I kind of like to think of it as I'm getting rid of the loose guy, right? I don't want to get rid of the one tight, best friends with that x. They're super close, but this other one hanging on here towards the end, that's the one I'm going to move first. But it is the opposite of order of operations. So I'm going to add or subtract first. In this case, the opposite of minus 1 would be plus 1. I'm going to show by thinking because those are going to cancel each other out. So I'm left with negative 2x on the left, 9 plus 1 equals 10 on the right. Notice how I'm showing my adding 1 on both sides of the equal sign. And then finally, now I have negative 2x equals 10. Again, remember that means negative 2 times x, right? So the opposite of multiplying is dividing, and we're going to write that dividing with a fraction bar. So I'm going to divide both sides by negative 2. So I get x equals negative 5. Now again, I am quite sure that you guys should be pretty confident in solving an equation like that. I just wanted to refresh your memory, and remember, your goal and your focus is to show good work, keep it organized, because we are definitely going to get to harder and more difficult problems very, very soon. So you want to have this, this routine and this method all set up. Here we go, number 2, 4 minus 8x equals 60. Here's my equal sign. Thinking about my opposite of order of operations here, this negative 8 is tight to the x. It is attached, so that means it's multiplied. The 4 is the loose guy. Now, the tricky part about this is that that 4 is actually a positive 4, right? We are not subtracting 4 from x. The 4 is a positive 4. So the opposite of 4 would be to subtract 4. I want to make this 0. So if I have positive 4, I need to subtract 4 to get it to be 0. So I'm going to do minus 4 on both sides. So I bring down. Now be careful. This is another place that a lot of students goof up, is we forget to bring down that negative sign with the 8, right? This is a negative 8x, not just an 8x. So make sure you have that with you. So I have negative 8x equals 56. And now my negative 8 is right there attached to the x, which means it's negative 8 times x. So the opposite operation would be to divide by negative 8 on both sides. So I get x equals negative 7. All right. Oh, now these last two, here we have some parentheses. Hopefully you remember what we do when we have a number outside of parentheses. A number outside of parentheses means that we're going to distribute, right? Here I'm going to see I see my equal sign, so I'm going to draw that line. But hopefully you're remembering that a number outside of parentheses means you're distributing that number. So when I distribute, that means that I'm going to multiply. So first I'm going to multiply negative 3 times x, which gives me negative 3x. And then I'm going to distribute, I'm going to multiply negative 3 times 2, which gives me negative 6. Watch those symbols, right? Negative 3 times positive 2 would give me negative 6. Now, you could write plus negative 6 if you want, but I'm going to try and simplify it. Keep it as clean and organized as I can. Negative 6 is the same as subtracting 6, so I'm just going to write that negative once, but plus negative 6 is the same thing. All right, and then I'm just bringing down my equals 18 because I didn't do anything with that one yet. And now I'm right back to basically like number 1, so hopefully you're feeling pretty confident. Negative 3 is being multiplied by x, so I can't move that first. I've first got to move the minus 6, so in order to do that, I do the opposite, which is adding 6 to both sides. So I get negative 3x equals 24. Divide both sides by negative 3, and I'm writing it with a fraction bar. So I get x equals negative 8 is my final answer. All right, last one. Similar idea here, right, as I'm distributing. Now, maybe some of you are really thinking, and you're thinking, well, if distributing is really multiplying, couldn't I just undo the multiplying right away? This is 100% optional, but I am going to show you 2 ways to do this last problem, just in case this is occurring to someone else and you would like to do it this way. So by all means, you for sure can do this problem exactly the same way as the last one, where I distribute my 2. So I get 6, and then 2 times negative x would be negative 2x equals 6. The other way I could do it, though, excuse me, is I could say, okay, this is 2 times 3, the quantity 3 minus x. So I could divide the whole thing by 2, and I would get rid of that 2 right away. Right? So 2 times the parentheses. If I want to do the opposite of times, I would do divide. So I would divide by 2. Now the 2's will cancel on the left, so I'll still have that 3 minus x in parentheses. Technically, though, if I don't have anything else on that side, I don't need the parentheses anymore. I'm sorry, that's a little bit hard to read, so I'm going to clean it up. 3 minus x is over on this side. And then on the right side, I did 6 divided by 2, which equals 3. So both of these ways are excellent. You can do either one, doesn't matter. I'm guessing most people are going to distribute. Honestly, I distribute most of the time. That's kind of just how I work, right? That's just the first thing that occurs to me. So I'm going to keep going on that one. So I'd subtract 6 on both sides because that's the adding or subtracting, right? The negative 2 is being multiplied by x, so I can't do that first. The 6 is positive, so opposite of positive 6 is minus 6. So those will cancel over on the left. I get negative 2x equals, 6 minus 6 on the right, well, that cancels as well. Now be careful. If you are on this side, the right-hand side over here, there's nothing left. There's absolutely no more numbers to write down. So over here, if I have nothing left, how do we write nothing in math? I write it by writing 0. The reason I don't have to write the 0 over here on the left-hand side is because there's other things to write. 0 minus 2x is just negative 2x. So if I have other things left to write, I don't need to write the 0. But on the right-hand side, these were just gone. There's nothing else, right? So I have to write the 0 in that case because there's nothing left on that side. Now, a lot of students get a little confused here and they think, am I done? Negative 2x equals 0. How is that going to work? But I'm not done yet, right? I can still get rid of that negative 2. It's negative 2 times x. So if it's negative 2 times x, I'm going to divide both sides by negative 2. Now it's all right. Negative 2 divided by negative 2 gives me 1, right? So 1 times x is x. Those cancel on the left. Again, just explaining my thinking here, right? On the right, what's 0 divided by negative 2? 0 divided by negative 2 is just 0. So x equals 0. But make sure that you are not done. Whoa, sorry, my pen stopped writing. Not done at that step. You need to keep going until you get that x by itself all the way down to x equals 0 and make sure you're showing your thinking on how you got there. Now, if you wanted to do the whole method I had on the right, you'd end up with the same thing, right? If you wanted to do that, you could, but you don't have to. You could always distribute. But if you wanted to over here, I would get rid of my 3 next. I'd have negative x equals 0, right? Again, I have to write the 0 on the right because there's nothing else there. And then, oh, I'm not quite done yet. This negative x, well, what's that invisible number written in front of the x if there's nothing written there? The invisible number is a 1. So this is really negative 1 times x. So to get rid of that negative, I'm going to divide both sides by negative 1. And again, I still get x equals 0. So either way is perfectly fine. You can distribute, or if you're really thinking about it and you say, I just want to divide, you can divide right away to get rid of that number in front. Just be careful that you don't end up with a fraction because that gets messy. All right, guys, hopefully that was a good review of your solving and that you are feeling confident in these basic problems. We're really going to kick it up over the next couple of days. So if you're not sure about anything, make sure you ask your questions.